Hi guys, and welcome back to Aisha's Academy. So in today's video, I will be doing the probability Edexcel higher paper. I know this has been quite high demand, so yeah, let's get right into it. Okay, so the first question shows a table of probabilities that a biased dice will land on a 2, 3, 4, and 5 and a 6, and the 1 is empty, the probability for the 1. And it says name our rolls the dice 200 times, and it wants us to work out an estimate for the total number of times the dice will land on a 1 and 3. So we have everything else. The only probability that we don't have is the probability of a 1. So remember that total probability adds up to 1. So to work out the missing one, you have to do 1 take away the 0.17, take away the 0.18, the 0.09, the 0.15, and take away the 0.1. That'll leave you with an answer of 0.31. So now we know the probability of it landing on a 1. To work out the number of times, you would have to do probability times total number, so like total times in this case. So that's 200 in this example, and that would give you the number for that specific probability outcome. So in regards to working out, we'll work out the total number of a 3 first. So now the probability of it landing on a 3 is 0.18. We know that it's the total number of times of rolls for all the numbers is 200 times. So multiply them together into your calculator, that will give you an answer of 36. So probability of it landing on a 3. Then the probability of it landing on a 1, you would need to do 0.31 times 200, and that would give you an answer of 62. Then to work out the total probability of a 1 and a 3, you need to add them both together, which would leave you an answer of 98. Then having a look at question 2, it says that there are only blue cubes, red cubes, and yellow cubes, and it wants us to show that the probability it says the table shows the probability of taking a blue at random, which is true, but the red and the yellow is not filled in. It says the number of red cubes in the box is the same as the number of yellow cubes, so it wants us to complete the table. Well, since they're the same, if we know that total probability again adds up to 1, and we do 1 minus 0.2, that gives us 0.8, which is the total probability of red and yellow. And because we know that they're the same, if we just divide that by 2, that'll give us 0.4. So that makes sense because they're the same. So if it's a case of where they're both the same, you divide by 2. If it was a case of where, let's say, the red was 2 times, I don't know, the yellow, you would divide by 3 and then times by 2 for the reds, and then just times by 1 for the yellow. So that's literally that bit. Then it says there are 12 blue cubes in a box. So it says work out the total number of cubes in the box. So if we know that there's 12 blue cubes, and we mentioned the equation briefly earlier, that probability times total number equals outcome number. So our outcome number is 12. Our probability for blue is 0.2. And we're trying to work out the total number. So to work that out, we will do 12 divided by 0.2. In your calculator, that should give you an answer of 60. So that means the total of red, blue, and yellow is 60. Okay, so moving on to question 3. So it says that question 3 is a scatter graph that shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. So I'm just going to go more into the graph. So this is the graph. So each cross is just representing one town's temperature and the number of hours for that town, the number of hours of sunshine. So the first thing is that it says one of the points is an outlier, and it wants us to write the coordinates of that. So an outlier is a point that doesn't look like it really fits in with the rest of the points. And the one that really looks out of place is this one up here. So in order to work out coordinates, remember it's x first and y second. Remember, because x becomes before y in the alphabet. So looking down, if we work out its x value, I'll zoom in. Okay, so its x value, if we go down, looks like it's landing at 10. Its y value landing at 19. So I'd say 10, 19 is the coordinate. So 10, 19, and I'm just going to rub out the lines because we won't need them anymore. Okay. So if we now scroll down to the the next part of the question. So it now says that on the same day in another British town, the maximum temperature is 16.4 degrees, and it wants us to estimate the number of hours of sunshine in this town on this day. So whenever it comes to an estimate question to do with scatter graphs, there tend to always be 2-mark questions. So your first mark will always come from drawing your line of best fit. So remember that your line of best fit, so if I write that down, remember your line of best fit is the line that best fits all the points on the graph. So that's roughly my line of best fit. So that's from the first mark. And the second mark is you need to draw across from the point that they've given you and then down to work out the value. So if it's 16.4 degrees, you would draw a line from 16.4. So again, I'm going to zoom in so it's clearer. So from this graph, we can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 little squares for every 2 numbers, from 16 to 18. So then each little square would be representative of 0.2. So if I've got 16.4 degrees, it would be there. Then I need to draw a line across. Obviously, yours would be neater on paper, and then down. Okay, so that's giving me an estimate of, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's about the same distance compared to the y-axis. So I say that's about a value of 12.9 degrees. This question was on a paper before, and to be fair, the mark scheme did say to allow a range between, I think, 12.8 to 13. So 12.9. So that's the end of that part. And then it goes on to say a weatherman says, let's zoom in to see what the weatherman's saying. So it says the weatherman says that the temperatures are higher on days when there's more sunshine. Does the scatter graph support what the weatherman says? Well, let's have a look at the graph. So as we look at the graph, we can see that as the number of hours, let me make it straight. Yeah, we can say that as the number of hours increase, so does the maximum temperature. So yes, we can say that the weatherman, we support the weatherman's statement. So there's either way you can write it, as long as you basically go along those lines. So anything along the lines of the graph shows that as number of hours of sunshine increases, so does maximum temperature increase. Therefore, we do agree. Or another way you can word it is, if you know from your revision of scatter graphs, you can see that the type of correlation that this is showing is a positive correlation. So you could also say that the graph does show a positive correlation between the number of hours of sunshine and the maximum temperature. Therefore, we do also agree with the weatherman's statement. So anything along those lines is fine. So a positive. Obviously, you would not put abbreviations like me. I'm just rushing. So going down to question 4, it's given us a table of weekly earnings and frequency, and it wants us to estimate the mean for the weekly range. So when it comes to these questions with frequency tables, we need to make a column for the midpoint, and it's going to be the midpoint of the weekly earning values. So I'm just shortening it for M for midpoint. So the first one would be 200, because that's halfway between 150 and 250, and then 300, 400, 500, and 600. Then you need to do another column, basically multiplying your midpoint of the weekly earnings times the frequency to work out the actual total number, like the total. So that's going to be, so for the first one, it will be 200 times 1, which is like 200. And then 3,300, 2,000, that's 0, that's 1,800. Use your calculator and add them all together. So adding them all together would leave us with an answer of 7,300. So So now that we've worked that out, the total, we know that mean is like your total divided by the total number of numbers. And we can see that this out of 20 people, because even our frequency should add up to 20 as well. So then the last bit is you're going to do that 7,300 divided by 20. And in your calculator, that should leave you with an answer of £365. So that would be the mean weekly earning. Okay, so going down to what Nadia is saying. Nadia is saying that the mean may not be the best average to use to represent this information. Do we agree with Nadia? Yes, we do agree with Nadia, because unfortunately, let me go back up. Unfortunately, when it comes to working out the mean from frequency tables, it doesn't exclude any outliers, any potential outliers, or any data that may not best fit the rest of the graph. So the problem is that our calculation may include some anomalous data. So therefore, the mean is not exactly the best average to use. So something along these lines. You don't have to write what I'm writing word for word. Anomalous data. Okay, so moving on to question 5. I don't know why this has come out like this, but I will redraw the circles. Okay, so we'll call that C, B, and A. Okay, so we just need to complete this Venn diagram. So the first thing is that this part in the middle here where the dot is where they all have a number in common. So looking at the data, they all have an 8 in common. We're going to shove 8 there. Then we can see that B and C, and we'll cancel them out so we don't get confused. We can see that B and C both have a 20 in common. So that would go that part where B and C share. And then we can see that C has a 22, the rest of them don't. So 22 will go there. A has a 14, and the rest of them don't. So 14 will just go there. A also has a 2, which the rest of them don't. So it's on this one. And then A also has a 10, and the rest of them do not. So it goes on its own. And lastly, C has an 18. So then it would go there. And then cross that out. And then we can also see that B has a 6. So the rest of them don't. So that's going to go there. Then we are not finished yet, because remember with Venn diagrams, you have to take into account what's going to go on the outside. And it basically says E, which is the part on the outside, are even numbers between 1 and 25. So all the even numbers that are not represented in the Venn diagram are going to go on the outside. So in case you forget one, what I would literally do is think of your even numbers from 1 to 25 and go in order. And then check, okay, whatever's in the Venn diagram, don't write that down. Whatever's not in the Venn diagram, write that down. So I'm going to start from 2. So 2 is there, so I'm not going to write that down. 4 is not there. So 4, 6 is there, 8 is there, 10 is there, 12 is not there. 14 is there, 16 is not there. 18 is there, 20 is there, 22 is there, and 24 is not there. So those are my even numbers that are not part of the Venn diagram. And this is how it should have actually come out, but it's okay, we've done it now. Okay, so now having a look at part B, it says a number is chosen at random from E. And it says find the probability that the number is a member of A, and then it's got this sign B. Write out like this again. So that sign means and. Always remember, because and has an N in the middle. So that means the probability of A and B. So looking at this 3-way Venn diagram, actually we'll look at this and then we'll go back to what we actually drew. So what is strictly A and B is just this part. It's not going to be the middle part, because that's A, B, and C, and we just want strictly A and B. So now, if we have a look at the Venn diagram that we've drawn, unfortunately, we can see that A and B don't actually have any values in that part of the Venn diagram. So it's actually 0. But the last step is we need to count the total number of numbers that there are and say what it's out of. So remember, when you're counting the total number of numbers, include what's inside the Venn diagram and the outside of the Venn diagram. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12. So we can say Fortunately, the probability is 0 out of 12. Okay, having a look at question 6. Again, we've got another frequency table. And this time, for part A, it wants us to find the class interval that contains the median. So remember, median is your middle value. And the equation for working out what the actual median number is always n plus 1 over 2. So that number. So our total n is 80. So 80 plus 1 will be 81 divided by 2. That's going to be the 40.5th number. But luckily in this table, you just need to find basically where you could just either find where the 40th number is and the 41st number, and you should actually find that they're both in the same place if this confuses you. So having a look now, we're going to count down the frequencies. So it's definitely not the first one because that's 4, that's 15, that's 39. But this one is 61, so it is definitely somewhere in here because we know the 40.5th number is somewhere within this range. So in terms of writing out the actual answer, I want you to write down the class interval, remember? And remember, this column is our class interval. So you're literally just going to write 160 is less than h, which is less than or equal to 170. That's all you need to write is your final answer. You don't need to write anything else. And then we're going to draw a frequency polygon. So as a recap, which I do have a video on my channel if you need refreshing, but in order to draw a frequency polygon, remember you need to find the midpoint first of the class intervals. So if we quickly do that, I'll put M for midpoint, so that's 135, 155, 155. I'm going to rub this out so I have enough space. Then I'm going to carry on. So that's 165, 175. So now that we've got the midpoints, what you're going to plot on is your midpoints are going to be the x values, and then your y values will be frequency. So it's always from midpoints. So if I zoom out, so you can so you can see both. Okay, so 135 is there. That's value of 4, which is there. 145 is here. Value of 11. 155 is here is a value of 24. 165 is a value of 22. And then 19. Nope. 19 is here. Okay, and then the last step with the frequency polygon, after you've plotted all your points, you need to connect them together. And the reason why they have that name is because apparently they're meant to look like a shape, so polygon meaning shape in maths. And remember, when you're connecting them together, don't be doing curves. I mean straight lines from one point to another. Straight. Ignore the terrible drawing on my end. It's digital, but on paper, with your ruler, draw your nice, neat lines. Okay. So moving on to question 7. So it's box plots, which I also have a video of. So it basically wants us to draw the box plot from this information. So there's always 5 key things in terms of drawing your box plot: the lowest value, lower quartile, median, upper quartile, and the higher value. So let's see what information we have and see what we can work with. We've been given the least height. So the least height is your lower end of the whisker. So that's a value of 154, which I'm just going to draw a line up there. Then we've been given the median, which is 165, so I'm going to draw my line for my median. Given lower quartile, which is 161, but the other ones are interquartile range and range. So remember, your interquartile range, which I've abbreviated as IQR, is your upper quartile minus your lower quartile. We don't know what the upper quartile is, which we do need to work it out to plot on the box plot. So to work it out, you're going to do IQR, so rearrange that equation, plus your lower quartile. So that's going to be 7 plus 161, these two values. And that would give you 168. So we know the upper quartile is 168. I'm going to draw a line up from there. Then last but not least, we need the highest value. So I'm going to connect the box together. So we need the highest value, which we don't have, but we can work it out because we know range is the highest minus the lowest. Again, rearranging it, range plus the lowest would give us the highest. So we would end up doing 20 plus 154, which would give us 174. So we know the highest value is 174. So if I draw a line on 174, and then that's going to be the rest of my box plot. So remember, the parts of the box is lower quartile, upper quartile, in the middle. Okay, all right. So then it's now asking us to compare between the box plot that we've drawn and a box plot for year 7. So it says compare the distribution. So again, when it comes to compare the distribution questions of box plots, there's two things that you want to compare, which I do mention in my video, but I'll repeat again for those that haven't watched it. All right, so you want to compare the medians, then you want to compare either the ranges or the interquartile ranges. So here, it doesn't really matter which one we'll do. I'm just going to do median and ranges. Okay, so as we can see, the median that we had was 165, but the one that they have is looking like it's directly in the middle. That's about 157.5. So first of all, we can say the median for girls for girls in year 11 is higher than the median for girls in year 7. So then I'm just going to put in bracket the values, which is 165, 157. Try and mention values in your statements just to back up your evidence. Then the next point is in comparing the ranges. So if I go back up, the range was 20. So the range was 20. And then here I'm going to work it out. So this value here is 146. This one here is 170.5. So if I did 170.5, take away 146 in my calculator, so that would give me 24.5. So I can see that the range is higher for those in year 7, but the range for girls in year 7, 24.5, is higher than the range of girls in year 11. Okay, and that's it. That's it to get your 2 marks. So compare those two things. Oh, and I don't know why I drew. Okay, so moving on to question 8. So question 8, we've got a probability tree, and it basically wants us to complete the probability tree. So let's look at this first. So first thing is that we know that the total branches, the total 2 branches add up to 1, because we know that total probability adds up to 1. So in order to, if we know the probability of winning on a Saturday is 0.45, then probability of not winning on a Saturday will be 1 minus 0.45, which is 0.55. Now, it says that if they win on a Saturday, the probability that they win on a Sunday is 0.67. So that's the information's up here, 0.67. So probability of winning on a Saturday is here, and the probability of winning on a Sunday is 0.67. So that means the probability of not winning on a Sunday when winning on a Saturday is 0.33, because that's one takeaway, 0.67. Then it now goes on to say that the probability that they do not win on a Saturday is if they do not win on a Saturday, the probability that they win on a Sunday is 0.36. So not winning on a Saturday, but winning on a Sunday, 0.35, not 0.36, sorry. So then you would work that out by doing 1 minus 0.35, which will leave you an answer of 0.65. And that is literally that part. Then it says find the probability that the team will exactly win one of the 2 matches. So to do that, remember to work out the probabilities of 2 different events. two independent events, you need to multiply them. So then it's going to be 0.45 times 0.33, because the probability of winning on a Saturday and not winning on a Sunday, and then the probability of not winning on a Saturday times the probability of winning on a Sunday, because then at least you won at least one of them. So you would end up doing 0.45 times 0.33 plus 0.55 times 0.33. And in your calculator, that'll give you an answer of 0.31. Okay. Then moving on to question 9, it says on the grid, draw a cumulative frequency graph for this information. So we have our cumulative frequency table and we have the graph down below. So before we just plot on whatever they've given us, cannot do that yet, because actually we can do that because they've given us cumulative frequency. So we're just going to plot that on. However, the key thing is that when plotting on cumulative frequency, you don't need to work out a midpoint like you did with frequency polygons. You need to plot on from the highest values in the class intervals. So for instance, your first point will be where the time is 40 and the cumulative frequency is 5, not when it's 30, not when it's 20. Always the highest value. So I'm gonna go find where 40 is, which is here. Find where 5 is, which is here. 60 and 25. And then 80 and 35. And then 138. And 120 and 40. And then remember, cumulative frequency is an S-shaped kind of graph. So it should look something like this. And then if you scroll down, it says, use your graph to find the interquartile range. So interquartile range, remember, is upper quartile minus lower quartile. So to work out your lower quartile from cumulative frequency, it's your cumulative frequency, so the maximum, the highest cumulative frequency, so max CF, times 0.25, so times a quartile. To find your upper quartile, it's going to be your maximum cumulative frequency times 0.75. So if we have a look at our upper quartile, the maximum cumulative frequency in our data was 40. So you're going to do 40 times 0.25, which will be 10. Then you're going to go, so this would be where our lower quartile is. So then you're going to go across from 10 down, down, and that is hitting at around 46. And so your upper quartile, you're going to do 40 times 0.75, which is 30. Then you're going to go across from 30 and then down. That's hitting around 67. Okay. So then to work out the interquartile range, you're going to do 67, take away 46, and that should leave you with an answer of 21. Okay, and then looking at part C, it says one of the people is chosen at random. Use your graph to find an estimate for the probability that this person took between 50 minutes and 90 minutes to complete the puzzle. So we're going to go up and we're going to find where 50 minutes is. So it's every two boxes. Every box is 2. So 2, 4, 2, 4, 6, 8, 10. So that's where 50 is. I'm going to run about the 46, so you can see that clearly. And I'm going to find where 90 is. Then I'm going to draw a line up to 90 and across. That is about 13. I lie. Let me draw that line. So that's about 30. And then where it hits 90 is about, because each box is 1, so that's about 36. Okay, then to now work out the probability between those times, I'm going to do 36 minus 13, and that's going to give me the numbers in between those times. So 36 minus 13 leaves me an answer of 23. And then having a look at question 10. So in this question, it is going to actually involve a bit of algebra. And I know that probably baffles some people, but I'll explain why. So what we're going to do is, because if I zoom in, so it says the probability that the counters are green is 3 out of 7. And it says the counters now put back in the bag. 2 more red counters are added, 3 more greens are added, and it says that the counter is taken out at random. Now, because more counters have been added, it says that the probability that the counter is green is 6 out of 10. We need to find the number of red encounters that were originally in the bag. So what we're going to write it as is, so we know the probability of the green first time was 3 out of 7. So another way of writing that is 3x over 3x plus 4x. 4x being the red, because it's only red and greens. And so the probability of the green second time is 6 out of 13, which is 3x, add the 3 extra counters, over 3x plus 3, because that's our new green, plus the red probability, which is 4x, plus the 2. Okay, so now that we've done that, what we need to do is we need to solve this. So another way of rewriting all of this is, if we look at the second one, we can rearrange it, and by multiplying the numerator of one side, denominator of one side by the numerator, and vice versa. So by doing that, that would leave us with, so first of all, we need to simplify this. So 3x plus 4x is 7x. 3 plus 2 is 5. So that's going to be 6 times 7x plus 5. And then the other one is going to be equal to 13 times 3x plus 3. And the reason why we've done that is because now we've gotten rid of the denominators, so we're no longer dealing with fractions. But because we have this kind of nicer algebraic layout, first thing that we are going to do now is we are going to expand the brackets. So that would leave us with 42x plus 30 is equal to 39x plus 39. Okay, so now that we have this rearrangement, we are going to collect the x's to one side. So then that's going to be the 42x minus 39x is equal to 39 minus 30. That's going to be 3x is equal to 9. And then that's going to be x is equal to 3. So therefore, because we know that x is 3, because we know that the green counters was 3x, the number of greens would be 3 times x, which was 3, is 9. So we know the green counters equals 9. Then the red counters was 4x. So then that would be 4 times 3, which is 12. So I understand why this could be a confusing question, but it's only because we wouldn't have been able to draw any probability trees or anything because the counter was put back. And remember, probability trees is good when either it's two separate events or when you're dealing with counter questions when they haven't put them back in the bag, when it's just been kept out. And so this was the only way, because also the probability had changed as well. So yeah. Okay, and then having a look at question 11, again, we've got another frequency table. These are very common. However, not to do with cumulative frequencies, not to do with frequency polygons, but to do with histograms, which are a type of kind of bar chart that's squashed together. So we need to draw the histogram. So if I, no. The first thing I'm going to do is so when it comes to histograms, you need to work out something called frequency density. So remember, with frequency polygons, you're working out midpoint. With cumulative frequency, you add them together. And then with histograms, you work out frequency density. So I'm going to call it FD for short. So the equation for frequency density is frequency divided by class width, aka this column. So in order to do that, the first one's going to be 15 divided by 10, which is 1.5. Then the next one is going to be 30 divided by 5, which is 6. Then it's going to be 51 divided by 5, which is 10.2. Then it's going to be 36 divided by 5, which will be 7.2. And then the next one is going to be 18 divided by 15, which is going to be 1.2. Okay, so now that we've worked out the frequency densities, I'm just going to write them. Okay, so now that we've worked out the frequency density, what we need to do is we need to now plot the axes on the graph. So if I have a look at the graph, I'm going to zoom, I know it's very zoomed out, but I'm going to zoom it out. So, okay, so this is our graph. So if we scroll up, we can see that the class width range is from 140 to 180. So what we're going to do is, and our class width is always the x-axis. So first thing that we're going to do is, because this is from 140 to 180, we're going to call this 140. Imagine there's that kind of squiggling around, we skipped everything else. 150, 160, 170, 180. Then our frequency density is what goes on the y-axis. So histograms, frequency density is on the y-axis, cumulative frequency is on the y-axis, and frequency polygons, just your frequencies on the y-axis. So here, we've got the highest value that we've got is 10.2. The lowest one that we have is 1.2. So having a look at our graph, I'm going to try with each big box representing 2 and see how that takes me. So 2, 4, 6, 8, 10, 12. Oh, just on, bang on. Alright, and then I'm going to plot the values in. So the first one was from 140 to 150. So because, remember, histograms are bar charts. I'm going to draw the lines on my bars. The frequency density was 1.5. So then for the next one, it was 6. Then for the next one, it was 10.2. And for the next one, 7.2. Nope, because it's going to 165, not 170. And then the last one was 1.2. Okay, cool. And then the last step for this, last question, by the way, for probability. So it says work out an estimate for the fraction of the students who have a height between 150 and 170. So you're going to be using the frequencies of this bar, this bar. Because it's up to 170, you need to work out the frequency of this bar. So remember, working out the frequency, so if we know FD was frequency over class width, then frequency is equal to frequency density times class width. So for that little bar, the frequency density is 1.2 and the class width is 5. So then it would be 6. So then, now for the other bars, we were given, so it was from, we're working out from these bars. So their frequencies are here. So add up in your calculator 30 plus 51 plus 36. That should leave you with an answer of 117. So these are all 117. Add that on to the 6. That would leave you with an answer of 123. Because it's a fraction, and wants you to estimate the fraction, we know it's out of 150 students. So it's going to be 123 out of 150. Simplify that as a fraction, divide by 3 on both sides. That leaves you with 41 over 50. So that would be our estimate. Okay guys, and that's the end of this video. I hope that was useful. Thanks for watching.